everyone. Today we will learn how to use transistor as an electronic switch and series voltage regulator. Let us understand with the help of the video. Session objectives. At the end of this video, you will be able to determine the minimum forward bias current required to switch the transistor from off to on condition, construct transistorized series voltage regulator and test, measure ripple at input and output of the regulator and find ripple factor. Let us briefly discuss transistors as electronic switches and series voltage regulators. The main applications of transistors are as amplifiers and electronic switches. To work, the transistor as an amplifier or switch depends on the operating region. Every transistor has three operating regions: the active region, the saturation region, and the cutoff region. These operating regions are differentiated by how the terminals are connected in forward bias and reverse bias. The DC supply is provided for the operation of a transistor. This DC supply is given to the two p-n junctions of a transistor, which influences the action of the majority carriers in these emitter and collector junctions. The junctions are forward and reverse biased based on our requirements. Forward bias is the condition where a positive voltage is applied to the p-type material and a negative voltage is applied to the n-type material. Reverse bias is the condition where a positive voltage is applied to the n-type material and a negative voltage is applied to the p-type material. These biasing methods make the transistor circuit work in three kinds of regions: active region, saturation region, and cutoff region. Active region. The transistor is typically employed in this mode as a current amplifier. Two junctions are differently biased in the active mode, with the emitter base junction being forward biased and the collector base junction being reverse biased. This mode allows current to flow between the emitter and collector in a proportionate manner to the base current. To work as an electronic switch, a transistor has to be operated in both saturation on and cutoff regions. Saturation region. Both the emitter base and collector base junctions are forward biased in this mode of operation. From collection to emitter, there is essentially little resistance to the free flow of current. The transistor is effectively a tight circuit in this mode because it is fully switched on. Additionally, circuits for switching and digital logic frequently utilize the saturation region. Cutoff region. In this mode, both collector base junction and emitter base junction are reverse biased. As both the p-n junctions are reverse biased, there is almost no current flow, except small leakage currents, which is usually in the order of few nanoamperes or picoamperes. BJT in this mode is switched off and is essentially an open circuit. Transistor as series voltage regulator. A regulator is a device that keeps power at the output terminals across the load consistent and regulated. Maintaining a consistent voltage at the load side becomes crucial due to voltage variations and load unbalancing. The device's performances and, by extension, the circuit are impacted by voltage variations. It is crucial to keep load voltage constant if the system includes sensitive loads like electrical devices. When handling sensitive loads, power quality is a problem, since undesired harmonics affect the load and result in undesirable losses. The regulator maintains the load voltage constant and free from harmonics. A transistor series voltage regulator can be defined as a device that keeps output voltage at a constant level. The transistor series voltage regulator acts as a regulating element. It takes the unregulated input and provides the regulated output. The circuit uses the transistor principle, which modifies its resistance with a change in bias voltage. It uses a Zener diode to maintain the base voltage of the transistor constant. It is frequently used in electronic circuits like voltage regulators, adapters, rectifier circuits, etc. to provide a regulator output voltage. The regulator is connected in series and shunts with the load based on the application. Let us collect the instruments and components to do these practical. Ammeter MC 0 to 100 mA 1. Ammeter MC 0 to 100 microampere 1. Voltmeter MC 0 to 15 volts 1. Regulated DC power supply 0 to 30 VDC 1A. Transistor BC 107 1. Lamp 6 volts 150 milliampere 1. Variable resistor 250 kilo ohms. Breadboard 1. Dry cell 1.5 volts 1. Transistor SL100 or equivalent 1. Zener diode 12 volts 1 by 4 watt 1. Resistors 180 ohms 1. 1 kilo ohm 2. 220 ohm 1. 330 ohm 1. Capacitor 10 microfarad 25 volt. LED red color 1. Hookup wires red and black each 1 meter. Task 1. Perform the using of the transistor as an electronic switch. Collect the specifications from the data book for the transistor BC107. Connect the circuit program as per the circuit diagram. Connect the switch S1, variable resistor 250 kilo ohm and microammeter in series to the base of the transistor. Connect the unregulated DC input to the circuit. Connect the milliammeter in series to the output. Connect the voltmeter in parallel to the output to measure the regulated voltage. Check for the specific range of instruments and correct polarity. Keep the supply off and voltage knob of power supply unit at 0 volt. Switch on the power and set the collector supply to 10 volt by operating the voltage knob. Switch on the battery supply by closing the switch S1 to the base emitter circuit. Adjust VR for base current of 5 microamperes and note the collector current and record it in tabulation. Change the IB to 90 microampere in steps as in the tabulation. Check the value of IB for which IC has not changed. That is, IC is saturated. Vary the IB base current between the two readings to find the exact value of IB at which IC reaches saturation. Set the IB to a value just above minimum to cause IC saturation and check for on-off action by operating switch S1. Switch off power supply. Connect a lamp of 6 watt 150 milliampere in the collector circuit and switch on the power supply. Check lamp glowing. If not, slightly adjust the base current to increase till the lamp is on. Confirm the lamp operation by operating base current of transistor. Draw the base to the collector current graph and mark the states of the transistor. Task 2. Construct transistorized series voltage regulator. Refer data book and record the required details of the given transistor. Test to confirm the condition of the given components. Construct the components in the breadboard as shown in the circuit diagram. Connect an unregulated DC voltage of 0 to 30 volts to the input terminals of the wired series regulator board. Switch on the AC main supply to the unregulated DC supply. Measure and record the input voltage and output voltage of the series regulator. Increase the voltage steps of 2 and record the corresponding output voltage in tabulation. Increase the voltage steps up to 16 volt and record. Beyond 12 volt in the output voltage, any increase in input voltage beyond 12 volt, 14 volt or 16 volt will not make any change in output voltage. Switch off and connect to the CRO to the input side and output side of the PS using dual trace CRO. Measure and record the ripple presentation of the circuit. Record it in tabulation. Thank you so much everyone for watching this video. I hope you have learned the objectives, how to use transistor as an electronic switch and series voltage regulator. Please do practice this with your instructors. Happy learning!